find various companies that are showcasing their latest products and services. We do also have a networking area where you can connect with other attendees and speakers. So do feel free to connect with all the speakers after the talk. And do not forget, we also have Sagar Ghosh, who is a renowned award-winning journalist, who will be hosting a panel on inclusive leadership conversation, what is diversity. And we also have Rushasthi Singh, who will be joining us at the end of today's program, who is India's top stand-up comedian. And please do stay tuned for another day of learning. Ladies and gentlemen, please welcome Bastin on stage.
Hello. So good afternoon to all of you. So today's topic is something called data-driven decision making. Most of the time, like we are talking about a lot of analytics and a lot of deep learning, machine learning, etc., etc. How many of them are aware of these things? Raise your hands. How many of them are not aware of it? Then it is for you. So, I myself, I'm a data practitioner. I've been working on different technologies like analytics point of view, machine learning, deep learning, etc. But today's talk is all about demystifying the thing and focusing on something what is real. Okay. So you will see a lot of technologies which just keep on evolving. Next 2-3 years or any 100 years, another 100 technologies will come and go. Right? But fundamental is same. It's the same English which you have heard and learning. Only thing is the combination is different. Today, the world of ChatGPT. Tomorrow, the world of another GPT. That's it. Right? So, when we say rise of AI, modern day you can see like everywhere you go, it's very simple that like AI is dominating, AI will replace my job, etc., 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 etc. Right? So, according to me, the rise of AI today is something which few years or hundreds of years ago has happened. That is nothing but rise of literacy. Right? So what is that common thing between these two? Let's see that. So if I'm telling like rise of literacy, most of the society thought that not everyone needed to have written communication, right? Those days. And most of them were in the fields, herding sheep, etc. The only person who, or only the group of people who need written communication were the priests and monks to read the holy books. For that, only that particular group of people wanted written communication, right? Olden days. Now, what we do, rest of us could go to the temple and church and listen to whatever they are teaching. And that's the only thing where this literacy was all about. Okay. But today, let's slowly move. And we see the modern day AI is in the hands of high priests and high monks, the big people. Agreed? Right. Now, who are these people who are the high priests and high monks of modern day? Are the highly skilled AI engineers, right? And the most important thing which they really need is they should be able to read and write code. How many of them can write code? Very rare. Okay. So We know that if you learn programming, you are going to get high-paying job. If you know programming, you will be the next big person, etc. But keep all this aside. Okay, let's come to the reality. Reality is like we write a hell lot of products, but nothing will go to the market. A product what you write with lots of programming language and lot of technology stack never wins. 90% of AI project fails. We'll say AI is everything. AI will only win if each and every one of you are able to use it. And regularly you should be able to use it. So that what? The problem is majority of decision makers does not know to read or write code. And that's not their mistake at all, right? People have your own domain expertise. And why should I go and learn code? Now the modern, if you go and pick anyone, he'll say, I want my kid to learn programming. Right? I want, and all the different types of organization, all the tech companies are forcing us that programming is very much needed. I would say only one thing. Even I teach for IIM. One thing which I commonly say is, let the kids be innocent. They don't need to be smart in this age. Innocence, what will happen if kid is innocent? It will fail, it will learn. It will fail, it will learn. And it will always make mistakes, and it knows that what is the consequences of mistakes. When that particular kid is growing up, it can take very precise decisions, and it will always have something called humanity with it. In this age, if you are over educated and over knowledgeful, then at one point you will be beyond the limits where you cannot manage it. So the first thing is that the kids be innocent. Keeping it that, we know that like everyone cannot code, and it's not advisable also, because an artist has different skill set, and a programmer has a different skill set. Everyone is needed, but now we can build a much richer society if we can enable everyone to write the future. That means whatever is there with this high marks, right, the skill set which they are having, if we are able to teach the same thing for all the others, then we can build a richer society. But that doesn't mean not teaching everyone to code, right? You want to use analytics, correct? But you don't want to use code. Why? Because my mentor always used to say, Robin, a person who really is a good data scientist may not be a great programmer. And a great programmer may not be a good analyst. Okay? So the main concept here is these skills are not directly connected. It's all we created. We created that hype, and in that hype we are floating. Now, how to do this? There is always something which I believe, that is, tools are important, but technique is everything in data science, right? Now, keeping this in the point, like, how many of them remember this sheet? Everyone. How many of them use this? Right? What is this? A stupid spreadsheet, right? Today, whatever analytical operations we are doing, when we go and approach to anyone, and if you say that, hey, I have built something very interesting product, like it can really help you to analyze things, it will auto-analyze for you and give you this summary, they'll say, hey Robin, like we already have spreadsheet, man. Can you do something on that? But unfortunately, most of tools, whatever we are talking, they are not compatible with it, right? They always believe that there is a very big group of people who are great analysts who regularly use only spreadsheets, not this advanced big tools, right? AI, deep learning, neural network, deep neural network, etc. But what if this same tool, what you are regularly using, is having all the power of whatever you needed? How many of them know that spreadsheet, if you really use it properly, that can really solve a lot of problems rather than you go and learn a new technology? How many of them know 100% Excel? 100% Excel or spreadsheets? How many of them? No one, right? Generally what we do, we just collect the data, keep it in silos, save it, XYZ, save it. But what if that decision making capability is there with spreadsheet, which which is not going to allow you to go to any other technology, be there itself. Wherever your data is, let the technology come to the data. It's not like you take the data, do the transformation, go to that place. And that's what we are going to talk about. So, machine learning models do not predict future. They just find patterns in the past historical data. And always remember, history repeats. Okay? So, today's modern day, junior data scientists are very eagerly and very busy building complex models, but the senior data scientists are very busy building the simplest models. Okay? Now, let's see the AI's long tail. Now, for example, you can see this is a chart which is showing that value of different AI applications with the potential. Okay. So today's talk is all about a lot of people will be having the high potential when you are able to build this contextual ad, recommendation systems, etc. Second thing is how can I make the web search much faster? Those are high potential and high value. But still there are places which are smaller, right? There are small SMB companies or lot of SMB organizations, they have small problems, right? I feel every single companies will adopt AI directly or indirectly in upcoming years, but not by means of programming or not by means of coding. But they will be using tools which can enhance that, right? Today everyone are using AI, but no one really knows where exactly AI is fitting in. Right from your mobile phone or the Uber which you are using or Google Map which you are using. Around 10 years before, if you take Google Map and put a destination, you will be standing in front of one lake and telling that you have to cross this. Right? Your Google Map will be very, very confidently telling, no, this lake, you have to go straight. Hey, yeah, there is no road. How can you go? But today, when you just give your destination, from the start to the destination, the ETA as well as all the aspects which a person requires is there, based out on its learning models, right? When you order something on Swiggy, you see an ETA. When you WhatsApp, you have a lot of technologies evolving internally, and it is provided in your simplest format. You go into Google search. If 10 people are sitting in this room, 10 people searching for the same word in Google, all the 10 will get a different results. Right? So AI is being applied in that, and now in next 10 years, AI is going to be a part of every single application where you yourself will not know this is exclusively the AI behind it. Because now the problem is we are having a bombardment of different data types, different data sources. Now there should be some interesting way to bring that particular needle from the haystack, right? So, is there a way to convert unpredictability into predictability? So, that's called ability to ask right question. Let me just ask you one simple question, like everyone there, are you able to see the screen? Okay, I'm just showing a very small data, okay? What is this data is all about? Structure. No, what's the data is all about inside this? Can everyone see from the behind? COVID. Correct. Because everyone has gone through it. What is interesting in that? How you understood there is COVID data? Recovery, new cases, death cases. Okay. Now all of you have come from for Analytical India's conference. Let me see what are the different types of questions we can ask to this data. What are the different types of questions you can ask only to this data? Okay, which country has the highest cases? Next. Okay, highest percentage of recovery to the death. Okay, next. Okay, on which date there was a peak? Next. Okay, duration of the pandemic and the different trends across state-wise, country-wise, district-wise. Okay, what are the other questions? Forecasting. Okay, we can forecast like what will be the next 10 days is all about. Next. Please, everyone participate. Just throw some answer, questions.
What does a case mean?
What is that?
What does a case mean? Like
What case mean? Here.
New cases, it's just new cases. So
New
what exactly
cases.
is a case?
Okay. New case is nothing but every day we know that the health department get date-wise the total number of cases, total number of recovery only on the COVID. Okay. Keep it only for the COVID. Yeah. Now.
Create timelines.
We can create timelines. Then.
We can make strategic decisions in terms of how much infrastructure will be needed.
Okay, we can make strategic decision on how to handle the healthcare infrastructure point of view. Okay, next. More.
Recovery versus death.
What are the different types of questions we can ask?
Personally,
Is this a history data or a live data?
Keep it with real-time data.
You
Yes.
can anticipate how much is required in terms of your oxygen cylinders.
Okay. Now there is a good question that like to predict and forecast what is the requirement of oxygen, etc. But do we have data for that? No. But that's a good question.
You only have those.
That's a good question which does not have the data. So we'll put that question as secondary data required. But that question is there still. More. What happened? We are in big data conference. Really, we are in a place where we are talking about big data, a lot of data, and we are talking about big technologies, but our data is very small. But why most of you are not able to ask the right question here?
Not sufficient.
What is the reason?
Sufficient data is not.
This data is there. It's a very, you won't believe most of our sessions, if I put this data, you'll get close to 100, 200 questions from that. What happened?
We don't have enough visibility of around what can this data can influence.
Okay, visibility is not there. But still, just give a try and see. What are the different questions we can ask in this data? What is the most interesting thing? For example, if I take this data, real data, and give it to you, and you will say, already all the analysis is there. So what? Something special I will look into it. Okay, one simple question. I will see during specific holidays, how is the cases impacted? Is it growing or lesser? Or death rates are more or lesser? On specific holiday, you can understand holidays based out on the dates. Or is there any country which is having the neighboring effect? That means from this, again this spread is happening to the nearest. From the same data, I'm telling about the same data. But we are talking about big things, very big things. We are forgetting the roots. So we should understand one thing, the good analytical practice always start with asking the right questions. Okay? What is analytic point of view is like you have to create list of questions without seeing the data. Right? If I take a full data set and they show you, within 10 minutes we'll get bored because humans are not used of seeing the logs numbers in a spreadsheet. That's why I am only giving you the data points. So whenever you do any kind of analysis, first look only for one thing, that is, I want to see the data points and at least one single record. How the data are being varying, whether they are saying male as M, a female as F, or they are encoding with number, that's the only thing. Okay. When you get a good set of data, first thing is start asking the questions. List of questions which possibly you can ask with this data. Now you have a list of questions, you have the data. Now you need a spreadsheet to just go and filter it and plot different types of charts. Correct? So first thing what we look is everything normal in the plots whatever you are creating. For that what you will do? You will do some anomalous trend detection by checking is there any anomalies in the number of cases which is recovery or number of death rates or etc. You check for anomalies. Second thing what you do, if there is an anomaly, find what is causing that. Find the root cause. How to do root cause analysis? Do an even correlation and see like which is there any positive or negative or no correlation there. Third thing is predicting what can happen next. That is how much time is remaining. Okay? How much time is it? That's where your predictions now. Where you use forecasting, time series forecasting or any prediction models. Now, whenever you do all these things, you get a set of different data visualizations and charts, etc. Now you need to create a storyline from that, correct? So first thing is the abstract is nothing but find the story. First check in your data there is a trend. Is there any trend? First question is check all the data point and see is there any trend. If there is no trend, next check for is there any patterns. is there any specific clusters which are there. Third thing is check is there any extreme values, because majority of times these outliers will contribute to an effective story. Majority of times, because an outlier really shows that okay, something is weird or something is odd happening, and that outlier will be the point for a story. So first thing is find the trend. If there is no trend, check for the pattern. If there is no pattern, check for the outliers. Okay. Now choose how to tell this. For example, you needed to have an axis. What type of axis you have to use? The x-axis, what you are going to do, y-axis, what you are going to do, those things. Next thing is you need to use it aesthetically pleasing by giving the right kind of color code. Okay. First thing is if there is a trend, okay, you can see that trend initially was dull, now it's making some sense. And when there is a pattern, I am using different colors. And if it is an outlier, I am exactly showing only on the outlier, I don't want other things. Right? So focus on annotating in the proper way. Next thing is you start narrating the story. For example, in the trend which is growing up, I am plotting, okay, the goal was exceeded at that particular point. And next thing is two groups were identified in the clusters. Third thing is an unusual finding. Okay? In a simple graph which you can do, plot it on your spreadsheet, you can do a lot of things like this. Now, use visualization to enhance your message. First thing is find your story through exploratory visualization. Second is choose suitable representation for your story. Use aesthetics to highlight your finding and support with appropriate messaging. 4 important things. And now coming, learn to log the data. You talk about model, you talk about tools, techniques, everything. If data is good, output is good. If data is crap, garbage in, garbage out concept. So always I say, before starting any analysis, you should have an understanding whether my data has enough quality so that I can proceed with it. Most of the time what happens is in the modern day, you ask anyone to build an analytical model or machine learning model, they take some data set and they do some transformation, they'll run a model and they'll show, oh, my model is able to predict breast cancer 90% of time correctly. If you really ask the question, whether your data is biased, I don't know. Whether you have enough quantity of data that you are telling that your assumptions are correct, I don't know. So most of people miss that part that data quality audit is a part of this entire pipeline. Only if that pipeline 100% you are clear, then you know what is the outcome. And a really good data analyst or data practitioners will always tell what will be your final outcome without building a model. You don't even need to build a model. If you really understand your data better without building a model, I can tell that okay, this model will give you only 50% accuracy because of such and such reason. This model will give you 90% accuracy, but that will literally fail in the real time. Okay, so now I am talking about model and all these things, right? We people are absolute beginners. We don't know the code, right? Now let's see a little more deeper here. Meet Richard. Okay, Richard is considered like a fictional character. He's a CEO of a company called Simplify. Okay, it's like an Amazon, but it's a small scale Amazon. Only in one small state it's running. Now, every day Richard is also interested to increase his ROI, right? We cannot exclude him, right? Just because it's an AI and I need very complicated, sophisticated cloud technologies and high-paying cloud technologies, just because of that, I cannot ignore Richard. He's a small guy. Like that, you will be having small businesses. Your father will be having small businesses. Or your mother will be having small businesses. What if they get this power? Now, who will give that power? That's a question. There is power everywhere, but who is going to give the power? Now, he wanted to know, okay, can I know my customers, segments like high-paying customer, low-paying customer, etc. Common question. You can put it across different verticals or different domains you get it. Second question is, can I know who is likely to leave my company? Right? Or, third thing is, what are customer product feedbacks about a product across geographies? 3 questions. Are they all 3 data questions? These 3 business questions, now let's convert it into data questions. From where data will come for each question, you need to know. For the first one, you will get it from the inventory. For the second one, I can go to the employee database and HR related software, you can fetch the data out of it. Third thing is customer feedback across geography. So I can gather data from all the social medias using the hashtags. The purpose we put hashtag itself is to fetch that particular hashtag and everything which is related to that. Okay. Now, take the first question, customer segmentation. You know what is a customer segmentation? I have lot of customers who are coming to my app, but my app is having only very small screen. In that, my inventory is having around 1 million or 1 million different types of product. All the 1 million products, if I put it into a mobile, will you buy anything? Will anyone buy the product? Searching itself, you will be taking a lot of time. So what if I am very cleverly knowing that based out on your first transaction with this particular app, I can understand are you a high paying customer or a low paying customer or a quality conscious customer, right? If I am able to understand that, I will group all the products accordingly. When you next time log in, I will just pick that particular group and I just show to you. Rather than showing this entire inventory, I can directly show that, right? For this, what is needed? We need a clustering technology, a method to cluster the data. Now we have data like this. Okay, we have customer data which is very minimal, where we have customer ID, their gender, their age, annual income, and spending score. Now, what if I am able to have one more new column called cluster? Okay, this customer number 1 belongs to cluster number 2. He is a high paying customer, or the customer number 1 who is actually cluster 2. Third customer is cluster 1. So if I am able to get this number, I just filter only that subset of customers and I just focus on targeting them, correct? Now how to do this? How to do this? This is the challenge. So let's take a simple example here. Internet is needed. So what we do is, there is this very small extension in Google spreadsheet. It's called Predict Easy. Okay, if you go to Google extension, there is a option called Predict Easy. That extension, if you install it, a very small Chrome extension, and in that you just select the data wherever it is there. Okay, yeah. Can you see the screen? Backside. You just select the data, and you just go and select the data range and how much clusters you want to select, and if you run a cluster, immediately the data will be plotted there. I mean, like the data wherever it is, here to that a new column will be created, which cluster these customers are belonging to, right? Without writing a single line of code, you can run a clustering on a spreadsheet. Okay. Number 2, after this session, I will just share the PPT so anyone can directly get the link and see the video, because that screen resolution is not really supporting. So, next thing, first problem, clustering problem, I can solve it using the video. You can get it after this. Okay. Second thing is employee attrition. Very big challenge. I really wanted to see who are the employees who are very likely to move away. Who are the ones who will stick with me. Now let me take, there is a list of different features are here. Can you tell any 3 which will contribute for a person whether they will leave or not? Age, okay. Past employment history, good. Job satisfaction. And hourly rate, okay. Now let's see from an analytical point of view. I have a data which is in the same add-on itself. You have an attrition data set. You just open it. There it is visible. So if you just open it, there is a place called data sets, and if you go and click attrition, that data set is automatically loaded into a spreadsheet where you have employee data set. I'm just going and clicking and inserting that. So the data gets loaded there, and in that particular loaded data, there is one column called whether this person has left or still there. Okay. Now I can just select the list of all the columns as target, like X variable. That means these are all independent variable, and I wanted to predict a dependent variable called whether he will leave or not. Okay, so X is all the independent variable and Y is the dependent variable. I can easily run a classification model on this, which will not build a model just like that. It will give you the factors with the scoring rank. That means what are the factors among all these 30, 40 different factors are there in different columns. Which are the one which is going to contribute for the attrition. So if I just go to this, you can see I am opening up a classification model. I am selecting the range of variables which I am going to give it as an input. Okay. So I am just moving all the X variables into one range rather than putting in the mixer of it. I am putting everything under one range, and I am selecting those all X independent variables, and I am selecting the range here. And next thing is I am selecting only the target which I wanted to predict. That means one column will be there called whether this person will leave or not. Attrition is yes or no. So I am selecting that column. Then I am giving few cross validation of around 0, 1 to 2 and run a model now. Now what happens is automatically the model starts building upon this data and it scores everything. You can see the model has built and the scoring has come. Now based out of this data we can see a person working overtime. That really defines whether a person will leave or not. Second important thing is, I can't see anything. Okay. So what happens is out of that 30-40 columns, the most important column which is responsible for that final outcome is being sorted. Now you can pick that 4-5 columns and say if next an employee comes, if I get this information I can say whether he will leave or not. What is the probability he will leave? The probability score is around close to 85% confident. Now what happened? We run a classification model on a spreadsheet. We didn't do anything else. Third thing is a customer sentiment analysis. Now we have a lot of data which is coming from different social media. Richard wanted to know the analytics of that. So he can pretty quickly go and pull the data. Yeah, you have that crappy Twitter tweets which is having a lot of characters and everything. You can just select that and run one sentiment analysis which each and every single record it will calculate the positivity and negativity and give it to you. Now all these things are possible with a no-code simple add-on, okay, which is called PredictPC. If you just go to Google Workspace or if you open spreadsheet and go to that get add-on, search for PredictPC, you can directly install it. It's free. Okay. Now, what I wanted to tell is code is not an asset, it's a liability. First, remember this. Second thing is tools are important, but technique is everything in data science. And this is the reality of today. Like the company boss thinks AI is the money printing machine. Okay. My customer thinks AI is a magical hat. What software engineers think is AI is nothing but it's a data science box where a lot of imports and exports are happening on the data modules. But what really AI and data science is all about, multiple people orchestrating an orchestra where a data provider, like a machine engineer, a domain expertise, everyone should orchestrate perfectly. That's what is all about AI. Now, always, this is a key takeaway. Data will talk to you if you're willing to listen. And if you're willing to listen means learn to ask the right questions to the data, and to get your analytical outcome, you don't need to be a programmer. And in next 10 years, that's going to be very solid. You all will be data practitioners without writing a single line of code. With this, I'm concluding my talk. So if you have any questions or anything to get clarified, I'm there. Thank you.